Welcome to this lab demo. Today we will show you how to use the oscilloscope in the signal generator. First, we are going to look at the oscilloscope, including an overview, how to measure the voltage and time, and the trigger function. Then we will look at the signal generator, including an overview, how to set the waveforms, amplitude and frequency. Now let's move on with the oscilloscope. This is the standard lab set in our lab. From bottom up, we have a DC power supply which provides DC voltages, an oscilloscope which we will use to measure waveforms, and at top a signal generator which generates different signals. The oscilloscope measures voltage versus time waveforms. On the vertical axis, or y-axis, it shows the voltage. On the horizontal axis, or x-axis, it shows the time. The power button is hiding at the top left corner. You need to push it down to power up the oscilloscope. It has two input channels, CH1 and CH2. The knobs above each channel input are the voltage settings for each channel. The next set of knobs are the time settings. The last set of knobbing buttons are for the trigger settings. Now let's look at the voltage measurement. Power up the oscilloscope by pushing down the power button. Connect the probe to channel 1. Connect one set of banana alligator cable to the output of the DC power supply, red to positive, black to negative. Connect the DC voltage to the oscilloscope probe, red to testing tip, black to reference tip. Adjust the CH1 setting to display the voltage on the screen. Change the DC voltage on the power supply and check the oscilloscope waveform changing along with it. The following video clip shows you the measured changing voltage. Now let's measure the voltage value. First, adjust the voltage settings properly. Coupling, DC. It should be set as DC most of the time. The only time you want to set it as AC is when you only want to see the AC portion of the signal, not the real signal. Remember, set it as DC, not AC. Probe, ×1. This is to match with the setting on the physical probe. If the probe is set as ×10, adjust the oscilloscope probe setting to ×10 as well. Use the bigger knob to adjust the voltage scaling. Here we have 5 volts per division. Use the smaller knob to move the vertical position. The number 1 here shows you the position of 0 volts of channel 1. How to measure the voltage value? The voltage equals the number of divisions times the voltage scaling. Here the voltage is 2 divisions above 0. The voltage value is 2 times 5 equals 10 volts. Now let's look at the time measurement at x-axis. We are going to use the calibration signal of the oscilloscope, which is a square wave with 5 volts amplitude and 1 kHz frequency. Connect your probe to it. If you cannot get a stable waveform on the screen, it might be your trigger setting is not good. We will cover the trigger setting later. When you get a stable waveform, use the smaller knob to adjust the horizontal position. Use the bigger knob to adjust the time scaling. Here we have 250 microseconds per division. How to measure the time? The time equals the number of division times the time scaling. For example, the period here has 4 divisions. The period equals to 4 times 250 equals 1000 microseconds equals 1 millisecond. The frequency equals 1 over the period equals 1 over 1 millisecond equals 1 kilohertz, matching with the signal. Now the trigger function. If the waveform is not stable on the screen, adjust your trigger settings. Push the trigger menu button to show the trigger menu. Use these small buttons to choose the settings. Here we set the type as edge, source is channel 1, slope is rising, mode is auto, and coupling is DC. Use the small knob to adjust the trigger level. On the display screen, the little arrow at the right edge shows the trigger level. The following clip shows you the effect of adjusting the trigger level. Now we are familiar with the oscilloscope. Let's move on to the signal generator. We will have an overview first, then talk about the settings of waveform, amplitude and frequency. The signal generator provides different types of signal for using in the lab. The output is a BNC connector at the right. The purple buttons determine the type of waveforms. We have square wave, triangle, and sine wave. The knob in the middle determines the amplitude of the signal. The frequency will be set by two parts. The gray buttons set the frequency range, and black knob sets the frequency factor. The output frequency equals the factor times the range. Now let's send the signal from the signal generator to the oscilloscope. Use a BNC to alligator cable for the output of signal generator. Connect the output signal to the oscilloscope probe. Adjust the settings of the signal, waveform, amplitude, and frequency. Adjust the oscilloscope settings to display the waveform, voltage scaling and position, time scaling and position, trigger settings. Then perform the measurement of three waveforms: triangle, square wave, and sine wave. Here the signal is set as a triangle waveform. The frequency equals 1.0 times 1 kHz equals 1 kHz. Here is the waveform on the oscilloscope. The measured period equals 4 divisions times 250 microseconds equals 1000 microseconds equals 1 millisecond. The frequency equals 1 over period equals 1 over 1 millisecond equals 1 kHz, matching with the signal. The following clip shows you the adjustments in the experiment. Here the signal is set as a square wave. The frequency equals 1.0 times 1 kHz equals 1 kHz. Here is the waveform on the oscilloscope. The measured period equals 4 divisions times 250 microseconds equals 1000 microseconds equals 1 millisecond. The frequency equals 1 over period equals 1 over 1 millisecond equals 1 kHz, matching with the signal. Here the signal is set as a sine wave. The frequency equals 0.6 times 100 Hz equals 60 Hz. This is the frequency in our power system, which we are using everywhere. Here is the waveform on the oscilloscope. The measured period is close to 3.4 divisions times 5 milliseconds equals 17 milliseconds. The frequency equals 1 over period is close to 1 over 17 milliseconds equals 58.8 Hz, matching with the signal. Now we complete our lab. Thanks for watching.